everybody, and welcome to another episode of Adventures in Machine Learning. I'm your host, Charles Max Wood, and I'm here with Chris Mattmann. Chris, it's funny because I saw his name pop up, and we emailed back and forth to set this up, and I was like, I've interviewed him before. And I was like, and I think it was a while ago. So I went and looked. It was 2011, and it was at ApacheCon in Vancouver. And yeah, it's been a while. So I did do a little digging. You're still at JPL, and yeah, it's been 10 years, but what else is new? I guess newish if it's been 10 years.
It's like, hey, it's a pleasure to be here, Charles. And what part of life is new? I mean, besides a global pandemic and, something that hasn't happened in 100 years. But yeah, it's just a small thing. Just a small thing. No, I was trying to remember even 2010, 2011. Gosh, I was a different person then. Besides even the weight, it's probably 50, 60 pounds away. No, yeah, I was really involved in open source a lot. I remember our interview touched on a lot of that, back then. And I'm still at JPL. My role back then was a little bit different. I was on the board of Apache back then, and I was really like an individual contributor making a lot of technology and trying to get it open sourced and things like that. And my role, recently in the past 5 years of JPL has been moving more into kind of like technical and people in line management. And I recently was appointed the Chief Technology and Innovation Officer at JPL, and now I manage our multifunctional innovation team in IT.
Cool, very cool. When I went freelance, I was still only a few years into my development career. My first contract, I was paid $60 an hour. Due to feedback from my friends, I raised it to $120 an hour on the next contract. And due to the podcasts I was involved in and the screencasts I had made in the past, I started getting calls from people I'd never even heard of who wanted me to do development work for them because I had done that kind of work or talked about or demonstrated that kind of work in the videos and podcasts that I was making. Within a year, I was able to more than double my freelancing rates, and I had more work than I could handle. If you're thinking about freelancing or have a profitable but not busy or fulfilling freelance practice, let me show you how to do it in my Dev Heroes Accelerator. Dev Heroes aren't just people who devs admire, they're also people who deliver for clients who know, like, and trust them. Let me help you double your income and fill your slowdowns. You can learn more at devheroesaccelerator.com. So yeah, it's few changes there. So you wrote this book on TensorFlow. How do you have time for that with 3 kids and everything else you've got going on?
My God. So I wonder that sometimes myself. So the trick with with the TensorFlow book was sort of a couple things. So, I'm a Manning author. I had written a book about 10 years ago called Tika in Action. I guess the best way to describe Tika is it's the digital Babel fish. If you like the Hitchhiker's Guide to the Galaxy, you put the Babel fish to your ear and you can understand any language. Tika is like the same thing for file formats. And probably its most famous thing ever was it helped solve the Panama Papers. You can look it up on Wikipedia. And so I get the books as a Manning author. They offer, I can say, I like that book or I want to read this book. All of my team is into machine learning, all the innovation people, whether it's PyTorch, TensorFlow, whatever, I didn't 2 years ago. I was like, what the hell is, I did some clustering and machine learning for my PhD dissertation, like 15 years ago, or whatever. But I was like, I really wanted to know what it was about. So I got a book, the first version of this book written by a guy, Nishant Shukla, who was a PhD student in computer vision at UCLA, graduated in 2017. And the first version of this book, Machine Learning with TensorFlow, it was a pleasure to read. I was like, hey, can I get this book? They sent it to me and I'm reading through it. But as opposed to just reading the book, one thing I did differently, and we were still going to work back then physically, pre-pandemic, is I took out a notepad and, I started drawing matrices and I started pulling out a Jupyter notebook and trying to code along with it. And what I realized after about 9 months of doing that, Charles, is that I had a crap ton of Jupyter notebooks, like solved problems, like basically everywhere where Nishant said, I'm training a classifier. You may want to grab the IMDb data set and build a sentiment classifier and blah, blah. I did it.
Right.
I took his like rando suggestions and did it. And so I looked and I was like, dude, these are hard. They're like graduate level assignments in doing it. And so, by the time I did it, I had enough content for a new book. I knew I had fixed all the bugs because, it had been years since he had published his book and TensorFlow changed.
Right.
And, also just side note on this is like, what everyone likes and they chase, I tend to do the other thing. I
Mhm.
like to just be different. So my whole team was like into the PyTorch and whatever. And so I kind of took it on myself. I was like, I want to learn TensorFlow just to be different.
Mhm.
And so yeah, I got into TensorFlow that way. I had enough material for a new book, and that's how I got started on it.
I gotcha. So is this a second edition of the other book then?
It is. It's a second edition of the first book. What it adds is about half a dozen, maybe that's I think 7 new chapters that I wrote from whole cloth. I revised all the
Mhm.
chapters, made all the code work again, and added and sprinkled kind of my voice into that. A lot of Nishant's voice is still there as well. And yeah, and then the new chapters I added. I mean, gee whiz, they're nothing. It's just building a production sentiment classifier that you could deploy. It's taking Android user positional data and
Mhm.
inferring what they're doing based on where you're walking from an accelerometer. It's training part of speech tagger, that compares with, the state of the art that was used in the
Mhm.
aperture pause tagger. Let's see what else. It's autoencoders. It's doing autoencoders for the CFAR dataset. It's training a brand new VGG facial identification classifier. And along the way, I recreated the VGG dataset, which wasn't accessible anymore. So it was like originally 2.4 million images of celebrities. Only about
Mhm.
1.2 million of them still exist. I made it available, distributed it on TAC, and we published a paper at Supercomputing. And then it wraps up with a new chapter on basically like, your home assistant, like Alexa. Oops,
Right.
sorry, don't turn on Alexa. Google Assist. Ignore me, Alexa. Google Home, and all that. The
Uh-huh.
same way, it's listening. It's an LSTM implementation of the Baidu
Right.
deep speech model that, I rebuild with TensorFlow and show you how to do that from whole cloth. Those are all the new chapters I added.
Very cool. Well, I'm still a relative new neophyte, new programmer at TensorFlow. I've downloaded it and I've fiddled with it some. But let's imagine that for a second that we have somebody that's brand new to this, right? They're probably a competent programmer in, a mainstream language like Java or JavaScript or something, or Python, because it seems like TensorFlow and Python are kind of the way to go. How do they need to start thinking about things in order to get started with TensorFlow?
Sure. And even I'll take it up even one level from that to get started with machine learning in general.
Mm-hmm.
So how does one machine learning, how do we do it? So basically, the way that
Right.
we do it is sort of recognize this. There's a couple of different steps. There's the step to train basically a model, which may be built from either like a mathematical equation, eventually a biological or neurological model, like a neural network or things like that. And
Mm-hmm.
what a model does is it captures basically input and some transformation of that input to typically some predictive output, or classification or a grouping of things and all of that. So we
Right.
start off by thinking of building a model, and there's a process to basically build that model and train it. And so you have to divide in your mind the training process to construct a model, then ways of evaluating how well that model is doing during the step which we call inference, which is
Mm-hmm.
using the model to predict something, and then deciding how well it predicts and does that, and so forth. And then that's an oversimplification, but that's the start. Now going down into TensorFlow to build a model, we divide the world up into tensors. And what tensors are basically matrices. They're either one dimensional vectors or linear
Mm-hmm.
equations that transform those vectors. And the vectors could be different things. Like you might be taking a vector of continuous number data that's the set of phone calls, the number of phone calls in a call center per month, and then trying to take based on the past and each data point in that vector of how many per month and predict how many you're going to have next year in the same month or something like that. So it could be continuous data, it could be discrete data. I give you a bunch of basically input classes. I give you an apple, a banana, and an orange. And then
Mm-hmm.
I show you a picture of a kumquat, and you try and tell me what it is, based on that, or something
Yep.
like that. And so data is continuous or it's discrete. And
Mm-hmm.
then you decide what type of model you're trying to build. If data is continuous and you want to predict something, we call that a regression model. You're trying to predict a continuous value or plot a line in like, two-dimensional space and then tell me what the next continuous value on that line anywhere is.
Right.
If it's a discrete input in that vector or that tensor, that matrix, and I'll differentiate tensors from matrices in a second. But if it's a non-continuous model, like a discrete model, like a set of categorical choices in a class where you're trying to classify something, we call that classification. That's building a
Hmm.
classification model. And those are the start. And by the way, this is how the book goes. I'm just taking you along the path of the book. The book is more than TensorFlow. It's the study of machine learning too. And I could have titled it Machine Learning with TensorFlows and Friends.
Right.
Jupyter, SciPy, Pandas, NumPy. All the
Hmm.
things that you need in Python to data science and to do machine learning.
Right.
But yeah, so then you got regression, classification, and then in those things you all need labeled data. You need both what happened in the past with some,
Hmm.
level of confidence, and then to predict the future. So you need that labeled data. The next step is if you don't have any labeled data, and I just give you a bunch of, say, vectors or tensors or matrices, and then I want you to tell me something about it. We call that unsupervised learning. And
Hmm.
the something you could tell me about it could be clustering. You want to group it, into different groups. Just like inherently, you might go to your collection of, I don't want to say DVDs because that'll date myself. I could have said I could have said Laserdisc, but beyond that, you go to a collection of Blu-rays, and do people even still have those? Anyways, so you go to your collection of
we have
Blu-rays.
we have them here.
Yeah.
So
Okay. Whew, I know. I'm all on Disney Plus and digital now too, but
yes.
we can talk about that later. But yeah, so you go to those and you inherently just group your Blu-rays, say by category or things like that. Guess what you've
Hmm.
done? You've done unsupervised clustering. No one told you what the groups were. You sort of inferred how they should be delineated, and
Right.
based on some features of the data. So then we talk about that. That's something you got to understand in machine learning. And then we round out. These are called traditional machine learning models because they don't, say, use a biologically or neurologically inspired neural network, which we can talk about later. But these traditional models, there's regression, classification depending on the type of data input, continuous or discrete. There's unsupervised learning. We didn't tell you the
Hmm.
labels. And then there's probabilistic models and things. And we actually cover these. I cover this in the book. They're called hidden Markov models. And basically what these are sort of like the following. Again, based on observations of what's happening. But the hidden Markov model makes an observation that what you see is not the direct cause of something. It's actually a hidden cause. And based on what you see, like say you try and look at the temperature and predict the weather, from
Right.
it. That's not a direct sort of correlation from it. There's
Right.
probably some other rationale for whether it's sunny, or whether it's going to rain and things like that.
Hmm.
Temperature is an ancillary feature. And so these hidden Markov models basically model the world such that there's observations, there's something that you want to predict, but you can't directly observe what's causing, the
Right.
thing that you want to predict. And so we cover those types of models, hidden Markov models. And then basically what we do is for each one of those theories, those model building theories that we call explainable models because they're based and rooted in math and statistics,
Hmm.
we have a set of new chapters. I have a set of new chapters in the book that give you a real example of building a real world data set from whole cloth, getting the data, downloading it, preparing it, and cleaning it. This is the magic trick. And I'm going to pause because I want to hear some feedback from you. But this is the trick, is that everybody thinks machine learning is easy, but what they don't, and I make this bare in the book, you got to do a lot of work to clean
Yeah.
data to make it clean for machine learning.
Yep. Yeah, that's something that we've covered on the show a bunch of times is just, yeah, if you don't have good data, then you wind up with a good model. And sometimes you'll wind up with a model that gives you the right answer for the wrong reason, or, it'll give you sometimes the right answer for the right reason. And sometimes, you get the idea, but um, the better your data is, the better your model is going to be. And that just follows along. But sometimes it is, like you said, with your temperature, idea for a second, right? Sometimes it's hard to know if the data is good or not, right? And so you've got to make judgment calls based on what's important to you and what kind of outcome you want from your model so that you can actually reliably get the kind of output you want. And sometimes the data set is going to be a more accurate guess than you could come out with on your own given the same data. And sometimes your data set's going to be complete and you'll be able to get with reasonable accuracy the answers you want from your system.
Totally. Yeah. And if you talk about where people are going in the field nowadays and some new and hot areas, like obviously the collection and preparation of labeled training data comes at a high cost. And so everybody's
Hmm.
figuring out how to do learning with less labels today. How do
Right.
we do zero shot, one shot learning, generative, type of approaches to solve things like that, and other types of sort of automation that can solve or close the gap. Everyone wants to pay a cent per label, like labeling cat videos. It's cheap,
Right.
and to transform the hard problems like labeling Martian geology, that you need a PhD for, into those, and not cent
Right.
problems, but maybe $1, $2 per label, and things like
Right.
that. So, yeah,
Yeah, and that makes sense too. The other thing is that some of the data may be easy to understand, like temperature data, or how much light there is outside, or what the wind is doing. But you may be trying to predict something that at that level you need the PhD for. And so it's not so much that you don't understand what the data is or what it means. What you run into is, I don't know if I have everything here that is important to the thing I'm trying to predict.
totally. Yep. Yeah. There's inherent. Sometimes we learn exactly what we meant to learn. We just, like you said, we didn't know it because we were missing the things
Hmm.
that we couldn't learn. Related to that. It kind of reminds me of a story. It's bias in machine learning, and this is a hot topic. Nowadays, both from
Oh yeah.
yeah, an ethical AI perspective. And, so the early smart car training data sets, and even still today, we have a challenge with this. The early smart cars had a big challenge, which was basically they tended to not stop when, unfortunately, they saw folks in a wheelchair, because the
Hmm.
frankly of the frankness of the matter is they weren't trained on data that had people represented in wheelchairs, or are
Right.
there other things, or people of color in different ways, or things like that. They'd
Hmm.
never seen them, and they didn't, there was nothing in those networks. We haven't talked about neural networks yet, but I assume the audience kind of knows, so we'll talk about these. But
Yeah.
yeah, the they hadn't seen it, so they didn't have a label associated with that class of data, and thus, so bias, creating data sets without bias,
Hmm.
learnability, the limits of learnability, these are all really interesting research challenges nowadays.
Yeah, I've heard some other ones where I'm trying to think of one that's not too offensive, but kind of gets the point across. I think the most poignant one of these was, they showed a whole bunch of pictures. They trained it on a whole bunch of pictures, and then basically they gave it a photograph of the gate to Auschwitz, right? And the machine learning said, "Oh, that's a park. That's kind of, that's a nice place to go and
Yeah,
and hang out, right?"
yeah.
And it's like, no, no, and yeah, it just doesn't have that context because nobody has given it enough data to train that context into it.
That's exactly right. That's right. And so framing this a little bit, in elements of the prior discussion, basically each one of these models has their benefits and trade-offs.
Hmm.
Like regression, has the benefit that it can predict any type of continuous data and things, and give you easy confidence on it because it can predict the variance or the bias between its prediction and those continuous types of model fittings that it does. Classification, especially if you use things like softmax, can also give you confidence, associated with the differences between classes and things like that. So they have hidden Markov models have a different advantage because they're explainable in the sense that they can tell you it's a series of basically multiplicative predictions along the way. So at each step,
Hmm.
that it imputes and infers things it gives you. So all of them have their, benefits and trade-offs in terms of what data they can do, and the model variability. And then, when you start to take data to it, like when you do classification and you're doing sentiment classification, you may only start out like trying to predict, say, just positive and negative sentiment, but you can do tricks at the end to basically differentiate the classes even further. I'm reminded of basically Facebook's or the social media companies rolling out of the reaction framework, which was like, love, hate, angry, sad, and things
Hmm.
like that. This was an interesting problem, and challenge, but it was very easily rolled out. Even without building a categorical multi-class thing, you could go from 2 classes to 5 simply by saying, what's the variance if you want to predict 1 or 0, where 0 is negative and 1 is positive, and you predict zero point 0.7. Well, I could
Hmm.
easily divide up the 0.5 to 1 range into 2 or 3 different classes and
Right.
easily just get the same thing. And so there's all sorts of interesting, not just modeling, but post processing tricks, that people can do to move from one model type to another, in the
Hmm.
space.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium. Right. So once we start talking about, okay, we've got this problem, we've got our data set, we've got the outcome or the prediction that we want it to make, how do we start pulling something together in TensorFlow?
Yeah. So here's the really cool part about TensorFlow. So TensorFlow's default sort of mechanism for doing things again is it follows that general pattern of both training, building a model, and then inferencing based on that. And it gives you a surrounding
Right.
sort of framework to do this. So the framework for TensorFlow is it is compatible with all the data loading and pandas and things like that, but it also gives you this what we call lazy executable graph, and it represents everything like a lazy, like as is, vogue nowadays with the Sparks of the world and all these data, lazy loadable graphs. TensorFlow doesn't just make a model, it makes the data loading and model inference training a model as well. Like, so say you have a series of steps to take a data set and do things like I talk about this in the book. So let's say that you want to take those audio files, let's say not audio files, let's say I give you a bunch of Android positional files, and it's basically each file is like an Excel spreadsheet. It is your over a 5-minute, 10-minute resolution. Each row in the spreadsheet is like 100 samples, say every 10 seconds of your X, Y, Z, T position, right? X and Y, Z is, the space, and T is over time at the time step. And so we take those positions from the accelerometer. We've got them in each of those files. And maybe what we want to do is we want to do some unsupervised clustering and find the people who, had similar, say, differentiations between their points over time. We call this acceleration and eventually something like jerk, right? Which measures the big fluxes between sets of points, or values over time. So to get this learning in TensorFlow, yes, here's the magic thing about TensorFlow. You can actually build a k-means clustering model in TensorFlow as a graph. Your graph may start out with taking these data points, preparing them, as a set of vectors or a matrice. So that describes some data flow process. Guess what you do in TensorFlow to do it? You load the data, you define your graph, which is a series of data flow operations. It may involve loading a CSV file, or even before that, iterating over a bunch of CSV files, loading them just using Pandas or CSV Reader in Python, and then taking them and putting them into a tensor matrix. That whole set of operations is only evaluated when you click go. That the data preparation steps, and maybe the steps to do k-means clustering on that is that we say, I think that there are, amongst the 19 participants and all of their points and the tens of thousands of rows of these 4-dimensional data sets, maybe I want to divide. I know that people were walking, climbing, jumping, or whatever, and I want to just fit this k = 5 to the different activities they were doing, their data points. And so k-means clustering is the process. It's an iterative process that the model building step for this, you can describe as a data flow graph as well. You start out in the data flow graph by putting the points anywhere, picking a random centroid, basically computing the distance from all the points to the centroids, updating the centroids based on it. And you do this, through 100 or 2,500 or however many iterations based on, it's a trade-off. These are decisions you make when you're trading your model. That whole set of things in TensorFlow is a data flow graph that you can describe and build or leverage a library once you've built this. You can leveraging Pythonics, capabilities to do object-oriented classes and library building. So, if you do this 10 times in TensorFlow, you're going to then build a library and people have around k-means, or even the model building part 2. That itself is a lazily executable graph. So not only is your data preparation and loading from CSV file to basically now doing a k-means clustering, itself a data flow graph, which means it's only going to evaluate when you basically do the reduce step or the go step at the end. And in this case, the go step are, say, those 5 classes you want of data points and what people are doing to basically infer based on people's positional data, what of those categories they fit into doing. Okay. So in TensorFlow, you describe this as a graph. There's not a ton of code. There's less code because you're only executing it then. And what TensorFlow figures out in the background for you are things like placement, what goes on the
Mhm.
CPU or the GPU. What it figures out, is like integration besides placement, of it, like how it should best split that data flow up in that data flow graph into series of jobs that can execute together or in parallel. It figures all that out for you. And then from a resource perspective, it basically then runs, and generates it. And at any time in TensorFlow, especially so in the original version of TensorFlow, you had to do all sorts of like extra code like TensorFlow 1, you had to basically define these placeholder variables and then inject data into them, or define the steps at which you take your Python data or your whatever data and put it in these tensors. In TensorFlow 2, one of the magic things they added is they said, hey, Python's a good language, object oriented, runtime. Let's just leverage Pythonic things. And so they did away with all the placeholders and everything else in TensorFlow 2. And you just write Python code and the data is injected from Python. And so basically the beauty of TensorFlow is it's a lazily executable graph. It figures out where to run it on GPUs or CPUs. And you can analyze that graph. There's something like TensorBoard that you can look at, say, the learning or variables that you tell it to monitor along the way. And these themselves are also just operations on the graph, completely independent of your actual data preparation, model building, and inference steps in the code.
That makes it sound a whole lot easier than I thought it might be.
Yeah. Well, and anyone, I'll just one other delineation that I think TensorFlow does good. It sounds like I work at Google. I'm a
Mhm.
fan, of it. Me, Charles. It's the open source in me. I've even had some PRs accepted. I fixed some of their documentation and their examples. But the thing I like about TensorFlow, different from maybe more modern machine learning frameworks, is most people just jump straight to
Mhm.
the unexplainable models. They go straight into, oh, well,
Oh,
we can,
yeah.
yeah, we can solve this. It's a classification problem. Let's build a neural network. Okay, sure, you can do. And so a lot of APIs. I mean, even I saw this a little with the Torch community. They're
Mhm.
kind of like optimized, assuming that's or fast AI or thing. They're assuming you're just going to go straight into building networks, and that's cool. And whatever, they're a little harder and they're more
Mhm.
unexplainable. The thing I like about TensorFlow is that process I just described is true whether or not that middle model step building part, you're building a biologically inspired neural network, an LSTM, an RNN, an autoencoder, whatever,
Right.
CNN, or if you're building one of the explainable models. It works the
Mhm.
same exact way.
Makes sense. So you've mentioned PyTorch a few times, and we've talked about PyTorch and we've talked about TensorFlow on the show, but usually when I get people to compare them, they basically tell you why the one they prefer is better than the other one, right?
Yeah.
And I'm a little curious, since you have people that work in PyTorch, and it sounds like they're getting work done in PyTorch at JPL. Um, is there a trade off to using one over the other? Is there an instance where I might pick one and not the other? And what are the differences?
Yeah. So for me, I think this really depends on your role, how much time you have, and
Right.
what you're trying to accomplish. So most of my folks at JPL, they laugh at me or they make fun of me and they call me a dinosaur. Heck, I'm still that's fine. I'm still dude, I was on the board of Apache. We're maintaining some web server there, from the NCSA 1990s days. So you'll
Hmm.
never kill me with using an old piece of software because you can teach an old dog new tricks. And but besides that, from what I've heard and what I understand, and I haven't deeply, done much at all or anything in Torch, so take this with a grain of salt. But my folks on the innovation team at JPL really do enjoy the Torch framework, and basically the best way I could describe it is it's high level API support, elegance, and
Hmm.
ability to get your job done. And so for them, they don't care. They weren't like me. They all came out with this knowledge. They came out of the Northwestern Analytics program, or they were already, people trained
Right.
today, I think were a little bit different trained than maybe we were back in the day. As we used to all be
Hmm.
mathematicians, but we called ourselves computer scientists because there was no computer science degree. Or,
Right.
now it's like they come out and they already learn math and stats and everything else. And I had to go back and like deeply put my head in the books when I was,
Yep.
getting PhD or whatever to do that. So, my folks come out and they don't care that they had to they already know regression or they already know all the low level APIs or they already know what injecting placeholders are. They get all that. And so they want a high level, elegant API to just get the job done and build exponentially. And so I'm like, from what I can understand, although TensorFlow 2 has solved some of those problems, from the TensorFlow 1 days, they already had a lot of buy-in because they embraced that first in the Torch community, the elegant
Right.
high-level APIs where TensorFlow exposed more under the hood. They said, especially in TensorFlow 1, oh, you want to create a variable? It's a placeholder, and you're going to have to bind the data to that variable,
Mm-hmm.
and you're going to have to do some extra steps and blah, 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 blah. Now, they added eventually, and now the other delineation is this. Some people, again, kind of like I just said, they don't build explainable models in PyTorch. Like they're literally just building networks. They're building CNNs, RNNs, brand new networks, all of these things. And, encoder decoders now, if you're working a
Mm-hmm.
lot in speech and stuff like that. And if you're only ever living in that world and you're never going to build a hidden Markov model, like I guess ask your next guest, or if you ever have this question, again, ask your community this. How many people are using Torch to build hidden Markov models? I would assume very little,
Right.
but many people are still doing traditional machine learning, and TensorFlow is a great framework to do that in,
Right.
but that's the trade-off,
Okay. Makes sense.
Yeah.
We've talked quite a bit about your book. Is there anything else in the book that we haven't covered that you think people ought to hear about? Because we're kind of getting toward the end of our time here.
The one thing I'll say about the book is I was you. And, I came into this with a topical, not very good knowledge of machine learning. If you are looking to pick up the book or read it to learn not just TensorFlow, but machine learning, I was you. And so what the book is really, 9 months plus a year of writing
Mm-hmm.
of my blood, sweat, and tears to make this easy for you. So now when you get the book, you go to the GitHub repo, there's a Docker. Both for TensorFlow 2, I've backported all the code to work on TensorFlow 2. It totally works. You can get the TF2 Docker, and you can get a TensorFlow 1 Docker if you want to use that, because that's still used up to 1.15. It uses circa a couple months ago, at least the latest versions of each, although these are changing. The data comes with the Docker too. So typically, the snake oil sometimes with machine learning is, oh, get my code. Oh, you want to do something with it? Well, go collect the data set and compare it, and stuff. I've already done that. So every example, you can click through all the Jupyter notebooks, run each cell. The data is already there. It's referenced locally. It comes on the Docker for you. I've collected all the data, including the new data. So you can run through all the examples, see all the, not just run the machine learning, but get an ROC curve for everything,
Right.
understand what an ROC curve are and errors and biases. It's all there.
So I guess the last question I have is, you're a director of something or other at NASA. Here, I've got it right here. Division manager. Is it? But you said that you moved up since then, right?
So the CTO or the CTIO at JPL, the
Mm-hmm.
Chief Technology and Innovation Officer, manages the innovation team. So a dual
Right.
hat that I have is I manage a multifunctional team of the innovation
Okay.
division. Yep. Mm-hmm.
So I guess my question is this kind of a hobby for you, or is this something that you actually use at work, or do you work with other people that use it at work?
Both. So for me, this is one of those things I believe is like there comes a point in your career, whether, in people management, technical management, some people pick or split. And if you
Mm-hmm.
pick people management, you lose your technical. If you pick technical management, you're going to be technical, but you're not the person to help that person's career.
Right.
You're more of an individual. Everyone always tells me you have to pick. I refuse. To me, I think if you want to do both, you kill yourself and you do both. And so that, for me, I had to understand what my people were talking about when they build stuff.
Mm-hmm.
And just to
Right.
let you know, from open source, like Charles, I still contribute to open source.
Yep.
Old Dinosaur here has some PRs accepted at TensorFlow because, I still want to help
Ooh,
people.
fancy.
Yep.
Yeah.
So
the other question I have is, what kinds of problems are you solving at JPL with these techniques?
So probably the best one I could say is sort of this. Let me explain it this way. So there's going to be a rover landing on Mars next week. Mars 2020, Perseverance. It is very similar to Mars Science Laboratory, which is the 2012 Curiosity rover. That was the
Mm-hmm.
last kind of like car size, Volkswagen bug size rover. That one had a bunch of instruments on it. So does this. This has even more. And the core mission of Perseverance is literally to find life. It's not like it's side mission and it's cool while it's looking at the rocks. If it finds its core mission is to find life. And so this Perseverance rover, which will land February 17th, it also has a helicopter on it called Ingenuity. It is the first. It's the Charles, Wright. It's the Wright brothers moment. It's the Wright brothers moment on Mars. Okay, and it's got a drone. This Ingenuity helicopter on it. Okay, so now really quick physics for you and your viewers. Earth to Mars is 8 minutes round trip light time. So we send a message to Mars. It takes 8 minutes to get basically the communication back from that. And so because that's a very, very thin pipe from Earth to Mars, we have to really use that very thin pipe efficiently. And the way that we do it is for Mars surface planning, the people that are going to plan what that rover does, for the next day, they're going to use 200 images a day to figure out where to go, where to drive the rover the next day, right? That's not enough. That doesn't give, because, the pipe's thin and images are expensive. What if tomorrow on the rover, we could put a TensorFlow model, because the rover, the old rover has like an iPhone 1 processor on it. It's got a Rad 750. The new rovers have like Qualcomm Snapdragons, not the rovers themselves, but like the Ingenuity helicopter has it. And future rovers will have high performance space flight computing on them. So we can run machine learning on them in the future. And if we could, what if instead of giving you 200 images back the next day to decide what to do for planning, I could give you back 1 million image captions? Text is cheap, right? I could give you back a bunch of captions of images using like Google's show and tell TensorFlow model. And, it might say planar rock on flatbed out in the distance, or it might say, cliff or this or sandy and rocky in some, description. And so basically, what happens kind of related to that is that that's all some of the stuff that our team is supporting. We're testing out next generation of deployment of these models to high performance spaceflight computing, including planetary rovers. And we want to enable that use case in the future.
That is cool. That is really cool. So, yeah. So I have to ask, just because now I'm curious. So is there any form of watching the rover land, or, watching the cameras on the lander or anything like that?
So couple things. So this rover, its entry, descent, and landing system, or EDL system, is very similar to the 7 minutes of terror video that you can see for the 2012, Curiosity rover from YouTube. This one is also outfitted with a camera on the EDL descent. So we will have video, but it won't be live streamed because of that 8 minute round trip time. It will collect it and eventually be sent back. But the most earliest, bestest, use of that very thin pipe is to send back engineering data and some first surface images when we get there. And that's going to be when everyone goes, yeah, and in a socially distanced masked way or whatever in the control room, and so in a different way. But we will have video of that. The other trick, we're going to have the sounds of Mars, so that it actually has a microphone on it. It's going to be able to record that. And it's got a lot of other things. So there will be a NASA EDL landing watch events. And if you go to the Mars public education site, you go to mars.nasa.gov, you can get all the links. There's going to be a several things like Zoom events, other events, watch parties, and there's going to be a whole program that JPL produces and NASA produces around this that I recommend to all your viewers to check out. It'll be a shining light in a difficult time, next Wednesday. I encourage everyone to watch.
Awesome. Yeah, I went to mars.nasa.gov. This is cool. So yeah, I think you just lost me about an hour or so of my time while I go check this out.
It'll be well spent.
Yeah, awesome. Well, I guess the last thing that we have is if people want to connect with you online, where do they go? So I'm assuming Twitter, GitHub.
Yeah, Twitter, GitHub. So I'm at Chris Mattmann, ChrisMattmann on Twitter. The same on GitHub. And go follow me on Instagram if you like seeing me dress up in various Marvel outfits, running around the Rose Bowl. I do Iron Man. I do the Avengers outfits. If you're watching WandaVision right now, come comment. I post a lot of Instagram WandaVision stuff. I'm a big Marvel fan. So
nice, very nice. And then on GitHub, you're Chris Mattmann as well.
Same. Chris Mattmann. That's the thing with me. I never give myself an alias. I'm Chris Mattmann everywhere. 2 N's, 2 M's, 2 A's, 2 T's, 2 N's.
Awesome. Very cool. All right. Well, we'll put links up. Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming. And I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit. And you can find that at summit.mostvaluable.dev. We have one more segment on these shows. I don't think we did it when I was doing Teach Me to Code, and that is picks. And so it's just a shout out to people. It's like, hey, look, this is something that's really great that I really love. I've been watching WandaVision with my wife and my kids, and we've been enjoying that. But I'll let you shout out about that if you want. A couple of things that I do want to shout out about. So my father-in-law, we got him watching Star Trek Discovery, and we had watched the first 2 seasons, and we were going to watch the third. We decided to wait for him, right? So we've been watching season 2 again, and it's a great show. I really, really enjoyed that. It's on CBS All Access, so you have to have all access to watch it, at least as far as I know. But we're really, really enjoying that. And then another show that I've been watching just on my own, and it's funny because I'll watch like 2 or 3 episodes, and then it'll be a few weeks, and then my wife will be gone doing something, and I'll be like, okay, I'm going to sit down and I'm going to watch another show, and it's The Umbrella Academy on Netflix. It's kind of a different flavor show, right? It's a little bit weird, but I like it. So I'm going to shout out about that. And then I just want to remind people, last episode I talked about the Dev Heroes Accelerator. If you're looking to kind of raise your profile within the programming community, that is weekly group coaching. You also get access to me on Voxer. And basically, the way I'm describing it to people is that I've had a few people say, well, I'm a senior developer, now what, right? In 3 years, I don't want to be doing the same thing in a different job, right? I want to keep growing. I want to help people, blah, blah, blah. Those kinds of things. I want to make more as a freelancer. And so, yeah, we get in, we help you kind of build some exposure and some influence so that you can do those things. And then you're going to sell more books, sell more courses, get a better job. All of those things kind of come out of that. So devheroesacademy.com. If you go there, there's a little bit of information there. You can also apply to be part of the accelerator. And yeah, like I said, we get on a call every week, and I just help people get through kind of becoming that influencer and get the exposure they want, so they get what they want from their career. Chris, what are your picks?
Oh, wow. I mean, I'm actually going to share Dev Heroes with my innovation team. That sounds pretty awesome. You're the second person that mentioned, what was the name of the umbrella show? The
Umbrella Academy.
Yeah, you're the second person today, believe it or not, that's recommended for me to watch that on
Yeah.
Netflix. So I've got to, I've got to get it sort of all over that. For me, let's see, what am I watching? Kind of sadly, I've been watching a lot of the news. I need to turn that off. There's an upcoming, special, that's really important, for me or whatever, and it has to do with, Kobe Bryant's death.
Oh, yeah.
and I've been watching, specials kind of about that, and kind of like on remembering Kobe Bryant, because that, I'm an LA guy, and I kind of grew up with him, and so that it's funny, everything kind of bad with the pandemic started just shortly after, everything happened, with him last January. I've been thinking a lot about that. But yeah, I mean, besides that, I just want to shout out to families, first responders, and everybody that's been really, helping during the pandemic, and everything else. And I hope everybody is doing all right with their family and safe, and getting by, because it's a struggle right now.
Yep, absolutely. Interestingly, the Kobe Bryant, I mean, love him or hate him, and I know there were people that loved him. I know the people that didn't like him, but he was a tremendous basketball player, and everything I looked at that he was working on after he retired, he had his hands in a whole bunch of stuff that was doing good for people. So yeah, it was really sad that we lost him. Was there a documentary or something that's coming out about him?
Yeah, there is. There's a documentary on Kobe Bryant, and I'll dig it up and send it to you. But it's a project that I saw going around on Twitter, and maybe you can
Okay.
share it with your listeners. But yeah, it's being worked right now. It hasn't been released yet.
Oh, okay. Yeah, we'll keep an eye out for that and see what we can do there. And then, yeah, definitely. I mean, I talk on so many of these shows that I forget to say, yes, please be safe and take care of each other. Keep an eye out for, the first responders and everybody else that's still out there, sometimes putting their life on the line for us. Cause yeah, it's so important. So thank you for that.
Anytime.
All right. Well, we're going to go ahead and wrap this up. Thanks again for coming, Chris. This was a lot of fun.
Thanks so much for having me, Charles. And let's do it again before another 10 years. So,
yeah, absolutely. All right, folks, we're going to wrap this up. We'll have another one for you in a week. And until then, max out. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.